Okay, friends, so today we're going to do the last section in Unit 11. I know I'm skipping 11.9, but I'm kind of doing that on purpose because I want to at least introduce you to quadratics in Unit 12 before we end the year. So today we're working with radical equations. When we start to solve radical equations, we have some steps right over here that are some nice steps. I mean, they're fine. We're going to isolate the radical on one side, do the opposite of what the root is telling us, and then solve the resulting equation, checking any solutions. So let's look at an example on this. Here's our example number 1. I'll put it right up here. We want to solve x. The square root of x is equal to 10. So now we've talked about the opposite of a square root is a square. So what I'm going to do is I'm going to square that side. And if I do it to one side, I've got to do it to the other. The square and the square root cancel out, leaving me with x is equal to 10 squared, which is 100. So now if we plug that back into the original equation for our check, we can do that. So plug in x is 100. So the square root of 100 is equal to 10. Does that work out? Yes, it does. Okay, so that's how we check things. So let's look at example number 2. Example number 2, very similar, but a little bit different. Okay, we've got a little bit of work to do. I'm going to get rid of this stuff because I want to leave my, whoops, I got rid of too much. I want to leave myself with a nice little blank slate for y'all. Let's look here. Now this one, very similar, yet different. Okay, so the first thing we need to do in this problem is we need to get the square root by itself. So look at your step 1. It says isolate the radical. Okay, in example number 1, that was already done for us. But in this one, we need to get the radical alone. So I'm going to subtract 8 from both sides. That gives me the square root of x minus 3 equal to 4 minus 8, which is negative 4. Oh, friends, I'm going to stop us right there. Because never, ever, ever can a radical equal a negative number. It can't happen. Because remember, inside a radical, you say a number times itself. Even if you had a negative number, a negative times a negative is a positive. The only way to get a negative answer is having a positive times a negative. That's not the definition of a square root. So this cannot happen. Okay, it cannot happen. A root cannot equal a negative number. It just cannot. Now I'm going to go ahead and solve it to show you why that can't happen. And when things like this can't happen, we say there is no solution. There is no number in the world that we can put in there for x that will work. And I'll show you what I mean. I'm going to go ahead and finish solving this in green. So if I'm, Joe Schmo and I'm like, I know now I got to square both sides. All right, let's see, Joe Schmo. What happens? If I square that square root, it goes away, leaving me x minus 3 is equal to negative 4 squared is 16. Add 3 to both sides. Add 3 to both sides. That gives me x is equal to 19. Okay, well, you're saying, well, Peacock, it has an answer. It has an answer. So let's check that answer. Let's check it. All right, so we're going to plug that in. We're going to plug that 19 in to the answer. Well, that says 8 plus the square root of 19 minus 3 equals 4. Now that's 8 plus the square root. 19 minus 3 is 16 equals 4. That's really hard to see. Sorry, y'all. That's 8 plus the square root of 16 is 4 equals 4. 8 plus 4 is 12. Does 12 equal 4? No, it does not. That does not work. And that is why it is false and there's no solution. Okay? So looking at this next set of problems, we're again going to work with these radicals. So in example number 3, oh, yay, it's already isolated for us. So I'm going to square both sides. So that becomes 2x plus 5 is equal to 64. Subtract 5 from both sides. I get 2x is equal to 59. Divide both sides by 2. X is equal to 59 halves. And I could make it a mixed number if I wanted to. What's that? 29.5. But I'm just going to leave it like this because you'll see in my check, watch what happens in my check. We'll check it right here. I'm going to plug that in, the square root of 2 times 59. Whoa, 59 over 2. My pen is awful today. Plus 5. All right, that 2 and that denominator of 2 cancel out. So that should be equal to 8. So that gives me the square root of 59 plus 5 equals 8. That's the square root of 64 equals 8. And that checks out. Okay? Sorry about that horrible pen work. Okay? So our last example, example number 4. Once again, it's not isolated. I haven't isolated the variable yet. So I'm going to go ahead and do that. I'm going to subtract 10 on both sides. That's going to give me negative 2 times the square root of x is equal to negative 10. Now I'm going to now you say, well, Ms. Pico, it can't be equal to a negative. Wait. There's still a coefficient out here. So I'm going to divide by a negative 2. Divide by a negative 2. That tells me now the square root of x is equal to negative 10 divided by negative 2 is positive 5. The radical is equal to a positive number, so it can work. So the opposite of a square root is a square on both sides. So x is equal to 25. And if I went ahead and did my check over here, I can plug it in. 10 minus 2 times the square root of 25 is equal to 0. That's 10 minus 2 times 5 equals 0. That's 10 minus 10 is equal to 0, and that is correct. Pretty short and sweet lesson. And here is your work, 1 through 21 odd. Tomorrow we will have a review day, and Friday we will have our Unit 11 test. I'm going to put it all up now. So if you want to go ahead, since this was a super short lesson, do your review and then go ahead and take your test. You're more than welcome to get it done quicker. All right, have a great day.